Find the intervals on which the following function is increasing and decreasing. So looking at our function, we want to find a derivative because we know that we can find our critical numbers by looking at where the derivative equals 0 or is undefined. I have a product, so I've got first times the derivative of the second. The derivative of e to the negative x is e to the negative x times the derivative of negative x, so that puts a negative on that term, plus the second, which is e to the negative x, times the derivative of the first, and the derivative of x is 1. So there's our derivative. I'm interested in where it is undefined or where it is 0. Now I do have an e to the negative x, and if I move that to the bottom of a fraction, I'd have 1 over e to the x, but e to the x never equals 0, so there's not going to be any place where this is undefined. So what I'm interested in is figuring out where that first derivative equals 0. So I'm going to factor an e to the negative x out, and that will leave me, I'm going to factor a negative e to the negative x out, and that'll leave me a negative 1. So I'm interested in where that equals 0. And as we talked about, e to the negative x never equals 0. If you think of the graph of e to the negative x, it looks like this. And of course, negative e to the negative x would just be a reflection of that, but it never does equal 0. So I won't get a critical number from there, but I will get one from this next factor at x equal 1. So now I'm going to draw me a number line, and my critical number is at x equal 1. This is where my first derivative is 0. So let's look on either side of this critical number. Let's check out 0 and let's check out 2 and see the sign of the first derivative. If I put a 0 in here, I have e to the 0 is 1 multiplied by the negative, so this factor will be negative. And if I put a 0 in here, this factor will be negative, and negative times negative will be positive. So this graph is going to be increasing from negative infinity to 1. Now let's put a 2 in, and I can see that this will be a positive, this will be positive, but then multiplied by this negative in front will be negative. So I'll get a negative here, and the graph will be decreasing from 1 to infinity. So I've got increasing from negative infinity to 1 and decreasing from 1 to infinity. Let's go ahead and see the graph here, and we can see exactly what we found. We can see our increasing piece. Here is the graph, and it is increasing. And then we've got our critical number at 1. It's a very slow increase right here. Stops increasing right here. And then we have decreasing from 1 to infinity. So we can see that our graph decreases after this point, and here is the point where we changed from increasing because of the positive first derivative to decreasing because of the negative first derivative. This is actually a graph of the derivative, so we can see that connection. The derivative is going to be positive until we hit that point of where x equal 1 and the derivative there is 0, and then the derivative value goes negative.